Hi folks, and welcome to this video introducing you to how to perform machine learning in Python. Today we're going to show you how to just load and manipulate data using a Jupyter workbook. So to start with, obviously following on from our video where you installed Anaconda, we're going to go ahead and open up the Anaconda navigator. I have it pinned down to my little bar here. It's this little green circle, but we're going to search for it. And all you're going to do is just type Anaconda into the search bar. You'll see it pop up, both the Anaconda prompt and the Anaconda navigator. We want to open the Anaconda navigator. That takes just a second for it to pull up here. You'll see the circle in the middle of the screen. And the Anaconda navigator is where we go to load up most of the programs that interact with Python. You'll see once it opens up, we have a number of options for different programs that we can use. We are primarily going to be using Jupyter notebooks. Just ignore the update for now. Jupyter notebooks, that's right here. I also use a lot of Spider. Spider is particularly good for things that are going to go into production, but if we want to do exploratory analysis or general machine learning, that's Jupyter notebooks are a good place to do that. To launch them, you're just going to go ahead and click on the launch button. They'll open up in a default browser. My default browser is Opera, so it's going to open up in Opera. It's going to open up the two things that you had open last, or whatever you had open last time, but really what you want to get to is this home screen. Now, this home screen is really just a fancy version of Windows Explorer or any of those the file windows that you get. So it's just a list of all of the folders in your username directory in Windows. So you're probably going to want to go to navigate to wherever you saved the example files. So mine is in Documents, and then we're going to go down and we have UMUC, and then we have Python example scripts. And there you'll see 3 of the example scripts that I've been working on so far. The one that we're going to load up is called Loading and Exploring Data, so I'm going to go ahead and click on that, and it's going to open a new window. You'll see a handful of things. This is the notebook that we're going to use to interact with our code. You won't see any code on the screen at the moment because it's all these text boxes, and these text boxes are explanations for what happens within the code. There's a couple of other things that you can see up here. Obviously you have a file menu where you can save, rename, and download various parts of the file. We also have this menu called kernel. Kernel will allow you to restart, change, basically wipe whatever you're working with as you go through. Sometimes that's helpful when we get to the machine learning portion, particularly when we get to the deep learning portion. If you have something that's running for a long time, you can interrupt and that will stop it from running. As we go through, you'll see up here in the top right the status, if anything goes wrong or if we lose the connection or anything like that. So in this script, we are going to demonstrate some of the functions, how you would do some basic data manipulation. So we're going to load up a data set, a popular data set for sort of beginner machine learning, sandbox machine learning, to do with the survival on the Titanic. We're going to import the data. We're going to use some functions within Python, and Pandas, in particular Pandas is a library that we're going to be using to get some summary statistics about our data. We're going to replace some of the values that are missing. We're going to remove some columns if there are maybe too many missing values, and then we're going to save the data as a new file. So sort of general purpose things that you need to do with Python in order to be able to manipulate and work with your data, very similar to what we've been doing with SAS so far in the course. Now, to run each of these cells, you'll see there's several cells, you just press Shift-Enter. You can run the text cells too, but obviously it doesn't do anything, but I'm just going to press Shift-Enter, and as we work our way down here, you'll see that this has moved, this blue bar has moved down to the next cell. If you want to edit a cell, you can click within it here, you can edit that, and then just save it by Shift-Enter. The first thing we're going to do is import libraries. I like to import all my libraries that I'm going to use at the beginning of my code because that keeps it nice and clean. So the 3 libraries that we're going to import are Pandas. Pandas is a data science library that has like data frames and data tables, various ways of working with all sorts of like data tasks that Python doesn't do natively, but that we need to be able to do in order to work properly with data, and particularly important for performing machine learning. Next library we're going to import is called Numpy, Numpy, N-U-M-P-Y. That is a mathematical library, so that has a whole bunch of all of the math functions that you'll need in order to do data stuff. And then we're going to import a library called OS. OS is just a way of working with the file system. Again, it has a number of functions that allow us to do different things with the file system. We're going to use it once. There's a number of other things that it does, and it's actually the first library that we get to. So when we import these libraries, again, we want to click Shift-Enter just to go to the next cell. It'll import those libraries. And the first thing we're going to do is we're going to set what is the working directory. Now, Python has a default working directory, but depending on where you use it and how the environment's set up, that working directory can vary. So I like to set it explicitly. The one thing to note about this is that the path has 2 slashes in between all of the folder names. So you'll see it's C://, 2 slashes in there. There's a complicated reason for that, which I won't bore you with, but anytime you put a library or put a path name in Python, you'll need those double slashes. So we're going to go ahead and set that working directory. Next, we're going to import our Titanic data. To do that, again, we're going to use this pandas.readCSV function. You'll see that when we imported pandas, we said that to refer to pandas, we're going to import pandas, and then to refer to it, we're going to call it PD. So when we get down here, what we're doing is we're saying pandas read CSV. So this read CSV function is within the pandas library. And then we're going to assign that to a variable called data. And data is going to be a data frame that consists of this Titanic passenger list.csv. So we'll go ahead and read that in. And then the first thing we're going to do is we're going to look at some of the properties of this data set that we just imported. So the first thing that we'll do is look at the data type for each column. And that lists out the column name on the left-hand side, and then the data type on the right-hand side. Int64 is going to be an integer. Object is a string. Float64, it's going to be a decimal number, and so on and so on and so on. Now, again, these data types have equivalents in SQL and in SAS. So int64 is an integer, which in SAS is an interval variable. The same with float64. Float is an interval variable in SAS. An object is a string, and Python is typically going to call that something nominal or ordinal. Python doesn't identify particular variables that have an order, which would be an ordinal variable. So now that we've pulled the data types in, we can look at a summary of our columns. We're going to use this using a method on the data frame called describe. What the describe method does is it pulls up some summary statistics for all of our columns. Now we're going to call it twice. We're going to do it the first time for the numeric columns, and the second time we're going to do it for the non-numeric columns. So here you see data.describe, and then inside the parentheses we've given it an argument. In this case, our argument says include, and what we've said we want to include is everything where the data type is a number. Don't worry about the mechanics of that too much, but mp.number, inside that include argument, that's going to pull up all the columns that are a number. So let's go ahead and run that. And you can see that below that, we have now a summary with various summary statistics of all of our different columns. Starting from the top, count is the count of all non-null values. That's important. The count of all non-null values. And you'll see that in several cases we actually have missing values. So 1309 is the number of rows in the data set. We have several missing rows in age. We only have 1046 non-null values in age. We have 1 missing in fair. And then body, which is whether the body was recovered or not from the Titanic, which we'll actually get rid of because it's a bit of a cheap variable. We have 121 values, so we're actually missing the majority of the values in there. Mean is the mean of those non-missing values. STD is standard deviation, min is the minimum, and then you have the quartiles and the max. Next, we're going to do the same thing, but you can see that instead of, so we're still using data.describe, but instead of including all the numbers, we're going to include all of the object variables. So that means that we're tagging it with this O number. That gives us a slightly different number. We have the count, again, count of non-null values. We have the number of unique values, and then we have the top occurring value. And then we have the frequency of the top occurring value. So you can see that we can get a number of summary statistics. It'd be similar to a stat explore node in SAS. Now, one thing that SAS does for us that Python doesn't do is SAS imputes missing values. So we can tell SAS with we give it a column name, and then we tell it what we want it to import. We tell it how we want to impute the missing value. We have to do that ourselves, so we have to make the decision. That gives us a little bit more flexibility, but it does mean that we have to do a couple of complicated things. So the first thing we're going to do is we're going to impute the missing ages. So you remember up here we only had 1046 missing 1046 values, non-null values in age, so we have to find out what the rest of them are. And the simplest way to do that is just to assign them the mean. So the first thing we want to do is we want to use this mean function. As I said, the mean function is part of the Numpy library, which is the one that we imported that I said was all of the math that goes on, a bunch of math functions that we find useful. So we want to find the mean, and the mean that we want to find is the column age, which is part of our data frame. So what this is going to do, it's going to find the mean of that column, and we run it, and the output is 29.88, so almost 30 years old. Now, to fill in the missing values, we need to know how to assign that value to specific rows within our data set where it's missing. To do that, we use a .lock method. So what this does is this method takes our data frame, and then we're saying and we're essentially saying locate, right? So data.locate, and then we want to give it a row reference and a column reference. Now, to find the right rows, right, we need to know whether something's null. And to tell you whether something's null, we have a function built into the Pandas library called isNull, and we're going to feed that a particular column. And this, behind the scenes, it returns true and false based on the rows, but what you really need to know is that when you put this function inside this row reference, it's going to return all of the it's going to return all of the null columns, and all of the null columns are the ones that we want to assign the value to. So that's good. The column name that we want to assign the values to is age. So the full function is our data frame dot locate all of the null rows. All of the null rows in the age column, and then assign the value to the age column. And the value that we want to assign is the average of the age column. So once we've done that, just run that. Once we've done that, we can take another look at our summary to make sure that we actually replace the right missing values. So now we'll go back, we're going to do our data.describe again. We're only going to include the number columns. We can find age right here. Now you can see that we have 1309 values in age instead of the ones that were missing. Now we're going to do the same thing with fair, because fair is also missing a value. So we're going to assign all of the null rows in the fair column. We're going to find all the null rows in the fair column, and then we're going to assign them the mean value of fair. So let's check that summary again and make sure all of those rows are imputed correctly, right? All right, good stuff. So we've gotten fair. Now, the body column is still missing values, but as I said, that's a reference to whether somebody's body was found, and we don't know that before the event. So what we want to do is we want to get rid of that column, essentially, because it's going to allow us to cheat. To drop a column, we just say name of our data frame dot drop, and then we give it a list of the columns that we want to drop inside those square brackets. Those square brackets make it a list. And then we do want to tell it the axis that we want to drop them for. Obviously, every data frame has rows and columns. Axis 0 is the rows, and axis 1 is the columns. So whenever we want to drop a column, we want to make sure that we put in axis 1. You can drop as many columns as you like doing this, so you could have a big long list of columns in here. For now, we'll just do one. And then to do that, obviously, once we've dropped the column, we want to make sure that we reassign that, because this will return a data frame. But we want to make sure that we reassign that to that data frame. Otherwise, we'll just get the copy and nothing will happen. We won't actually drop it. We'll just drop it and display it instead of dropping it and saving it. So let's go ahead and do that. Look at the describe function, and oh good, look, it's gone. So now we have the categorical columns to work with. There's a handful of columns in there that have missing values. Again, we're going to do a similar thing here. We're going to find that only really embarked, which is where the passenger got on, that's the only one that we're going to impute. Boat is another cheat column because that's which boat they got into. Obviously, if you got into a boat, they're very likely to have survived. And both the cabin number and the home destination have so many missing values that there isn't really much point in us working with them. So let's go ahead and drop the 3 that we don't want. That's cabin, boat, and home destination. And now let's put the S in the embarked column. So we're saying, again, we're just locating all the null rows, and then we're putting the S in the embarked column. And then obviously we'll check the summary to make sure that everything went as expected. And we are good to go. Right, so there's two more columns on there that we probably want to drop. Name and ticket both have full value, but the unique number of values is very, very, very high. So we have 1309 names, and 1307 of those are unique values. Obviously, I don't know who has the same name in this particular data set, but obviously we can get rid of those because that's not very helpful information. If every single row is unique, that's not telling us anything about what happened. Same with ticket. With 929 different values, it's unlikely we're going to get any information from that column, so we'll just go ahead and get rid of them now, and then do one final check again just to make sure that it worked. So once we've done that, every column is now completely full of values, and we've got rid of all the columns that we don't want. What we're going to do now is we're going to encode some of these values with 1s and 2s and 0s, because Python and deep learning in particular can't work with nominal or interval values, right? So we have to convert them into numbers. Again, this is something that SAS does, but SAS does it behind the scenes, so you may not see it on the front end, but this is exactly what SAS is doing on the back end. To do that, we just have to pick really just a number that we want to assign to each level, so each different value within the columns. I'll start with gender because it's a nice simple example. What we want to do is we want to create the column first. So we're going to create a column called gender, and we're just going to assign it the value 0. Now, when in the case of a binary value like in this case gender in the data set, so we have male and female in the data set. 0 I typically like to assign to the majority class. The majority class in this case is male. So what we're going to do is, again, we're going to use our data.locate function. We're going to find all the rows in the data frame where the column sex is female, and then we're going to put a 1, and we're going to put that 1 in the gender column. So let's go ahead and run both of these. And then we're just going to take a quick look at our summary to make sure that gender appears on the right hand side, and it does. Excellent. For the next one, we're going to do something called get dummies. Because we have more than 2 values for embarked, what we need to do is we need to convert all of those into a 1 or a 0, like a binary system, right? So we're going to have one column where people got on in Southampton, and if they got on in Southampton, it's going to be 1, and if they didn't, it's going to be 0. In the second case, we're going to have one where if they got on in Cherbourg, I believe, it's going to be a 1. If they didn't, it's going to be a 0. So essentially, we're going to create new columns in our data frame. To do that, the first thing we're going to do, we're going to use a built-in pandas function called getDummies, which just creates, takes one column, creates one column for every level within the first column, and then returns that as a data frame. So the first thing we're going to do is we're going to assign that to a data frame called dummies. Then we're going to take dummies and we're going to stick it on the side of our data frame. To do that, again, we're going to use a pandas function called concat, which concatenates the 2 data frames together. Concatenation basically takes one data frame, the other data frame, sticks them together. We can do this in this case because we're absolutely certain that the data frames have the same number of rows. It's very important. We need those 2 data frames to be the same size, otherwise they won't line up properly. The axis equals 1 just tells us that we want to do this column-wise, so we want to take one data frame and stick it next to the other so that we add columns. We don't want to add rows. And then we're going to assign the whole thing again just back to this data name that we've used all the way through. So we'll go ahead and do that. And then again, we're going to check the summary to make sure that everything went as expected. Oh, look at that. Now we have the gender column, which we created manually. And then we have the get dummies columns that we created on the right-hand side here with the places where people embarked. Next step is just to drop the last 2 columns that we recreated as numeric variables. So that's sex and embarked. Obviously, we've replaced those with number columns now. So we're going to go ahead and get rid of those. And then we're just going to do one final check to make sure all of the data types are as we expect. They are. They're all numeric variables. All right, so now we have a fully numeric data set that's cleaned up with imputed values, no missing values, anything like that. That's going to be a great basis for our machine learning. And we're going to save that as a CSV. And to do that, we just say we want to take our data frame. We want to save it as a CSV. We give it a file name. which in this case I said was Titanic numeric data only.csv. Call it whatever you want. Notice that there's no path in front of this. Because we set the working directory earlier on, this is going to save it in that working directory. So we know where it's going to be saved, because all the way at the top of our script, we set the working directory right here. And then finally, index equals false. Every pandas data frame has an index, which basically is a row number. Not really a row number, but it starts off as a row number. This appears in our CSV as a column to the left-hand side with no header. When we go to import the CSV into other programs, that can end up being a bit of a pain. So index equals false just tells it not to create that index column in our CSV. And then with one final press of Shift and Enter, we are done manipulating this Titanic data. So stick around, we'll have another video coming with how to begin modeling this data once we get a bit further through. If you have any questions, please reach out via my TA email address. Obviously, there is a space for comments on the YouTube video as well. I'll get a notification that you put that there. And we will see you next time.